Anaerobic exercise is an exercise intense enough to trigger lactic acid formation. It is used by athletes in non-endurance sports to promote strength, speed and power, and by bodybuilders to build muscle mass. Muscle energy systems trained using anaerobic exercise develop differently compared to aerobic exercise, leading to greater performance in short-duration, high-intensity activities, which last from mere seconds to up to about 2 minutes. Any activity lasting longer than about 2 minutes has a large aerobic metabolic component. Anaerobic metabolism, or anaerobic energy expenditure, is a natural part of whole-body metabolic energy expenditure. Fast-twitch muscle operates using anaerobic metabolic systems, such that any recruitment of fast-twitch muscle fibers leads to increased anaerobic energy expenditure. Intense exercise lasting upwards of about 4 minutes may still have a considerable anaerobic energy expenditure component. High-intensity interval training, although based on aerobic exercises like running, cycling and rowing, effectively become anaerobic when performed in excess of 90% maximum heart rate. Anaerobic energy expenditure is difficult to accurately quantify, although several reasonable methods to estimate the anaerobic component to exercise are available. In contrast, aerobic exercise includes lower intensity activities performed for longer periods of time. Activities such as walking, long slow runs, rowing, and cycling require a great deal of oxygen to generate the energy needed for prolonged exercise. In sports which require repeated short bursts of exercise, however, the anaerobic system enables muscles to recover for the next burst. Therefore, training for many sports demands that both energy-producing systems be developed. There are 2 types of anaerobic energy systems: 1, the high-energy phosphates, ATP-adenosine triphosphate and CP-creatine phosphate, and 2, anaerobic glycolyses. The high-energy phosphates are stored in very limited quantities within muscle cells. Anaerobic glycolysis exclusively uses glucose as a fuel in the absence of oxygen, or more specifically, when ATP is needed at rates that exceed those provided by aerobic metabolism. The consequence of rapid glucose breakdown is the formation of lactic acid. Physical activities that last up to about 30 seconds rely primarily on the former, ATP-CP phosphogons system. Beyond this time, both aerobic and anaerobic glycolytic metabolic systems begin to predominate. The byproduct of anaerobic glycolysis, lactate, has traditionally been thought to be detrimental to muscle function. However, this appears likely only when lactate levels are very high. Elevated lactate levels are only one of many changes that occur within and around muscle cells during intense exercise that can lead to fatigue. Fatigue, that is muscular failure, is a complex subject. Elevated muscle and blood lactate concentrations are a natural consequence of any physical exertion. The effectiveness of anaerobic activity can be improved through training. References